Hello and welcome back to the course on R programming. In the previous tutorial we talked a lot about vectors and we created some vectors, and I know there might have been a pile of information. We learned quite a few new functions. Well, today we'll quickly recap on what we learned last time, and then I'll introduce you to the square brackets. It's going to be quite a short tutorial, but also it is going to be quite an insightful one. So let's start by recapping what we learned last time. We learned three main functions for creating vectors. One is combine, where you take the letter C, which is the name of the function, and you put in some numbers or characters or whatever you want to store in your vector, and basically you combine them into a vector. All right, number two was the sequence function, where you specify the start of the sequence. By the way, it doesn't have to be 1. We've been using 1 most of the time, but it can be any number. And the end of the sequence, and then the step of the sequence as the third parameter. And this is going to be sequence. And finally, number 3 that we learned last time was the replicate function. So if we want to replicate something, whether it's a number, a character, or even a vector, we specify that object here, and then we say how many times we want to replicate it. And that is replicate. So now if I run all of these three together, I will get three vectors. And number 1, number 2 are a numeric, and as you can see here, this first one is just a combination of the parameters that we pass into the function. The second one is indeed the sequence that we wanted, from 201 to 250 with the step of 11. As you can see, 250 was not included, and that's because 11 doesn't fit evenly into the interval between 201 and 250, but that's okay. We're always guaranteed that we will be within the interval. And finally, Z, a character vector of 3 elements with the word high exclamation mark 3 times. Okay, so those are the 3 ways we learned how to create vectors. Now, what we'll learn today is how to access individual elements of a vector. Let me explain what I mean. Let's say we have a vector W with the following elements: A, B, C, D, and E. Now, this is a vector representing the start of the alphabet. If I run that and I print it out, I'll get the letters over here. So it's a vector of 5 letters. Now, how do I access these letters individually? How can I get access to the letter A by itself from this vector? Well, in order to do that, we need to use square brackets. So you need to type in the name of the vector, which is W, and then within square brackets, you need to type in the number of the element you want to access. And as you remember, especially if you're coming from another programming language background, numeration or indexation in R starts with 1. So we're going to put a 1 here, and that will give us access to the very first element. There we go, we've accessed the letter A. Same thing, we can access the second element, which is letter B. We can access the third element, and so on. Now, a good thing to know is that the square brackets in R are more versatile than in other programming languages. So if I want to, for instance, get access to all of the letters except for the first one, then I'll type in W minus 1, and I'll have B, C, D, E. Then if I want to get access to all of the letters except for the middle one, I will type in W minus 3, right? So I'll have A, B, D, E, so no C. And this is a vector. I can put this vector into another variable, so I can say V, W minus 3, and I will have another vector over here, A, B, D, E. And that is the beauty of R, because it operates in vectors. It is normal and is expected that sometimes when you access even a vector, but you specify what you don't want, in return, you will get back a vector again. All right, so what else can we do here? We can access several elements. So we can say W, and we can say elements 1, 2, and 3. So we'll put in a sequence, 1, 3. What does that give us? That's a 1, 2, 3 sequence. And now if we run this, we know that we want the A, B, C element. So basically we're passing on, this is a vector, 1, 2, 3 is a vector. We're passing a vector into the square brackets, and it is being used to tell the vector W which elements are required to be returned, which are A, B, C. So we can do that. We can do a different several elements. So we can say we want 3 to 5, for instance. So this will give us a vector 3, 4, 5. So there we go, C, D, E, right? And so this gives you the thought that you can pass vectors into the square brackets. So let's take it up a notch, right? Let's not just use the colon operator. Let's say we want to use the combine operator. So here we'll create a vector, and we will say we want element number 1, number 3, and number 5, right? So if I run this, it's a vector of 3 elements, 1, 3, 5. And if I run this now, we get ACE. So we get the first, the third, and the fifth. Okay, and what else can we do? Can we do the same thing with negative numbers? Of course we can do the same thing with negative numbers. We can say we want the whole vector except for -2 and -4. We run that, we get the same result, ACE. So it's exactly the same because we're passing on this vector of 2 numbers, -2 and -4, and it's excluding those. Now, can we use the colon operator with negative numbers? Of course we can. So if I just say -3 to -5 and I run that, it'll give me a vector -3, 4, 5. And if I run this now, W, -3, -5, it'll just give me letters A and B. So now if I create a vector with W and 1 to 2, I get the same result, A and B. So as you can see, there are multiple ways to achieve the same result in R, especially when accessing elements of a vector. And that's how it works, basically. So you've got many different options, and you can put in different parameters into your square brackets to receive what you're after and what you're looking for. Now, to finish off this tutorial, there are 2 things I would like to mention. First thing is that in this tutorial, we learned how to access the individual elements of a vector using the square brackets. It's a good skill to have, it's good to know, especially these are useful when you are putting a negative number in, because this information might come in handy when we're dealing with data frames further down in the course. But at the same time, what you will notice through this course and through your work in R is that you won't be needing to access individual elements of vectors that often. It might come as a shock to a lot of people coming from other backgrounds in programming, especially C, C++, and languages like that, like Java and so on. But R is a vector-driven language, and a lot of things happen in vectorized form. So I won't run too far ahead here, but in the next tutorial, you will find out exactly why you won't be needing these square brackets that much. So stay tuned for that. That'll be a very exciting tutorial. Can't wait for you guys to see it. And the other thing I wanted to mention is that you are now entering the world of R. And this is the part of your journey where, if you haven't yet, you're going to experience how steep the learning curve of R is. And even though we've done everything we can to smoothen it out a lot, you will still experience that it might, at this exact stage that we're in right now, it might start to become a bit more difficult to keep up with all these concepts that I'm literally throwing at you in these tutorials. Like even last time we spoke about 3 functions, right? So it takes time to understand these. So what I want to ask you is for you to become very, very exploratory and become very ask a lot of questions, like ask yourself a lot of questions. What can I do? What can't I do? What I want to further explore in R. So experiment a lot. That is how you can master this programming language and get over this very steep part of the learning curve. You need to keep practicing, and you need to switch your imagination on and say, for instance, okay, so what, like Kirill didn't explain, what happens if I put a number greater than the number of elements here? So if I put in W7, for instance, or what if I put in W102, or what if I put in W-7, or what if I put in W0, what happens there? Like, ask these questions, try to figure these things out, experiment, maybe look things up, ask me in the course, ask fellow students in the course, because you need to keep your brain working, keep your brain active in regards to this programming language. And even these 3 functions that we've run, there is so much you can learn about them. There's so many different combinations that you can use about them. And all of this ties into a very interesting concept that I learned about quite recently, which is called legometry. Legometry is the study of measuring what you don't know. So quantifying what you don't know. So LIGO is from the word shadow, and metry is from measure. So measuring the shadow, measuring what's unknown. And there's a very good TED talk on YouTube by Min Tufani on ligometry. He actually came up with this term. I highly recommend checking it out, and maybe that will inspire you to ask a lot more questions and experiment a lot with this programming language. And I look forward to seeing you in the next tutorial. Until then, happy coding. Hello and welcome to this tutorial on vectorized operations. Today we will find out why the square brackets aren't that important in R and what is the fundamental underlying concept driving this whole programming language. Alright, so let's get started. Let's say we have a numeric vector of 10 elements. And let's say we also have another numeric vector of 10 elements as well. And our goal is to add these two vectors together element by element. So what we want to do is we want to add these two elements together. We want to add these two elements, these two, these two, these two, and so on. So what would you do if you were programming this challenge in a different programming language, something like C or C++ or Java, or for that matter any other programming language that comes to mind? What you would probably do is you would create a loop, and in that loop you would have an index variable which would run from 1 to 10, and in every iteration of the loop you would add the corresponding two elements. So in the first iteration of the loop you would add these two and put them into the third vector. Then on the second iteration you would add these two, put them into that third vector as well. Then you would add these two on the third iteration, put them into the third vector, and so on. So you would actually loop through this. And that is the conventional approach, and it's called the devectorized approach. But in R, what you can do is you can simply just add the two vectors. Just simply put the plus sign between them like we're showing over here. Just tell R to add vector A to vector B, and it will do all of that for you in the background. So you don't have to actually loop through these. All you have to do is tell R, add the two vectors, and it will do it for you. And that is the fundamental underlying principle that R is a vectorized programming language, that everything happens in vectors already. You don't need to create these loops. Same thing for a subtraction operation, multiplication, division. Even if you want to compare the two vectors, so you want to perform Boolean operations or logical operations as we called them, you can still do that. So you can compare this vector, so vector A, let's say A greater than B, and what will happen is R will compare element by element, and you will have a resulting vector of, for instance, the first element in the resulting vector will be false, the second element will be true, then it'll be true, then it'll be false, then it'll be true, and so on. And of course you can compare the other way. So even Boolean operations you can still perform in a vectorized manner. And moreover, as we'll see from next tutorial, all of these operations you should perform in a vectorized manner. Alright, so let's see what happens if hypothetically you're trying to add a smaller vector to a larger vector. So you want to add a vector of 5 elements to a vector of 10 elements. What will happen in that case? Well, in that case, R will perform something that is called recycling of vectors. It will recycle the smaller vector. And the condition here is that the bigger vector should be a multiple of the smaller vector. So basically, the smaller vector should fit into the bigger vector a certain number of times without being cut off. In that case, basically R will copy and paste that small vector the number of times it is required, and then it will add the two vectors. So you should keep that in mind if you happen to add two vectors or perform an operation with two vectors of different lengths. And what happens if the greater vector is not a multiple of the smaller vector and you still want to perform an operation between them? Well, in that case, recycling will still occur, but you will get a warning from R. It will tell you that the greater vector is not a multiple of the small vector, and that's just something that R wants you to be aware of to make sure this is indeed the operation that you wanted to perform. And finally, as we saw previously, even with functions, you can use vectors. So vectors can be arguments within functions, and also vectors can be returned from functions performing their operations. Now, bear in mind that's not with all functions. Not all functions take vector arguments, but a lot of them actually do. And this second note over here, that vectors can be returned from functions, if you think of it from a C-type language or C++ language perspective, it's actually a very powerful thing. For those of you who know C and C++, how much effort do you actually have to put into your code for your function to return an array? Because ultimately an array is the same thing as a vector in C and R. So you have to go through quite a lot of hoops for your function to properly return an array and for everything to work okay. Here it's very simple because the vector is your basic element, is your basic building block of the programming language, which is R. And because R is based on vectors as a whole, it doesn't know any other thing. Remember that concept that we talked about, that even a single number is still a vector. That's because a vector is the most elementary building block of this programming language. Okay, so those were vectorized operations in R. Now you know how they work. I highly recommend that you take some time to practice these vectorized operations, to add a few vectors, subtract them, see what happens with different lengths of vectors, because in the next tutorial we will jump straight into an exercise that will show us why exactly in R vectorized operations are better. And I look forward to seeing you in the next tutorial. Until then, happy coding! Hello and welcome back to the course on R programming. In the previous tutorial we talked about vectorized operations, and I hope that you had a chance to practice some of those basic additions, subtractions, multiplications, divisions, and maybe some logical expressions with vectors in their vectorized form. And that is because I will leave that part for you to explore. In this tutorial we won't be going through those basics. In this tutorial we will straight away jump into a very interesting experiment. We will find out exactly why you should use vectorized operations in R over devectorized operations. So let's get straight into it. And this tutorial will consist of two parts. In the first tutorial, I would like to explain something to you about loops that might cause confusion if we jump straight into it in the second part. And as soon as we get that out of the way in the first part, we will proceed to our investigation. All right, so let's get started. First thing we're going to do is we're going to create a vector x, and we're going to put 5 random numbers into this vector. So we do it like that, we already know, and there are our 5 numbers. Now what we want to do is we want to print out each of these numbers or each of these elements on its own. How would we go about it from what we already know? Well, obviously we'd create a for loop, and we would say while I is in X. Remember how in the challenge we said while I is in R norm 100? Well, this is the same thing, just the difference is that we've already created this vector and we're already storing these 5 random numbers inside X. So we can say I in X, so while I is iterating over this vector. And then in the curly brackets we would say simply print I. So now if we run this, you will see that these numbers have been printed. So what exactly happened here? Let's just pause on this for a second. What happened here? What happened is variable I was created, which you can see over here. It's still alive. And what happened is this variable in this loop step by step went through this vector. So first it assumed this value, and then this happened. The value of this variable was printed, and that's why we see this here. Then the variable assumed this value, and then again this happened, and that's why we see this here. Then the variable assumed the next value, and then this happened again, and that's why we see this, and so on. And that happened 5 times. So that is how we are used to creating for loops in R. Now, let's say I wanted to print out these values of X using the square brackets. So let's say I wanted to print out the first value. How would I do that? I would say print, and then in the normal brackets I would say X, and then as we know from the square brackets tutorial, I would say X square brackets 1, right? So if I print that, you will see that I've printed just the first value. Now if I want to print the second value, same thing, X 2, right? And I can just copy paste this like a monkey 3, 4, 5. And so if I run this now, this is the second value, third value, fourth value, fifth value, right? So you can see that I've printed all 5 of them successfully by themselves. Now, what can you notice here? Okay, you can notice that every line here is identical. Out of these 5 lines, every line is identical. The only thing that changes is this number in the brackets, right? So it was a 1, then it became a 2, then it became a 3, 4, 5. So this looks like actually an iterative process, right? So you're doing the same thing, you're just changing one of the values. Well, whenever you see an iterative process, and whenever you can kind of think that you're doing a monkey's job, you're just changing one number, right? Well, then a loop can come in handy as well, right? A loop can take over and do this changing for you. So what would it look like? It would look like print x, and then in the brackets, instead of a number, we would have an index. So I, not this I, you know what, let's change it. Let's not say I, let's say j. We would have a number j, or a variable j, that would change from 1 to 5. And we would just use it here to iterate over this process. So what the I is doing here is a bit different. The I is actually iterating over the actual element itself. So that's the I, then that's the next I, that's the next I, that's the next I, and that's the next I. And this is like an R specific thing. What we're talking about here is for the J to iterate over 1, 2, 3, 4, and 5. So this is a more conventional approach that you would see in other programming languages. So let's turn this into a loop now. How would we do it? It's very simple. We just say for j in. Now we don't want to iterate over the vectors as we saw just now. We want to iterate over the numbers from 1 to 5. So we'll say from j, for j in 1 to 5. And then we'll put our curly brackets, add a tab, close the brackets. So what I want you to pay attention to here is that this loop, although it achieves the same result, is a bit different to this loop. Once again, this is, let's add a comment, this is conventional programming loop, right? And this one is called R specific programming loop, right? So here we are just telling J to iterate over the numbers 1 to 5, and then we're accessing the vector that we're interested in, x, through the square brackets, and by passing the value of j to the square brackets. What we're doing here is we're iterating over the vector itself. So I is actually assuming the values of the vector, and we can only do that because x is a vector, and that is how R operates. So this is kind of like a shortcut in R. Why I'm showing you this method now is because for what we're about to do, for the comparison of vectorized to devectorized operations, we're going to need to know how to do this loop, right? You won't be using this kind of loops much in R programming, or these kind of loops for that matter. But anyway, it's good to know, and plus we will need it today. So I hope that all makes sense, because you really need to get your head around this for the next part of this tutorial. And now let's proceed to that second part. So I'm gonna put a line here so that we know this is going to be the second part for today. All right, so what are we going to do here in our second part? Well, we're going to actually compare. So we're going to compare vectorized operations versus devectorized, right? So we've discussed that R is a vectorized programming language, and you can actually just add two vectors together without going through every single element. Now, what we want to see is, what is the difference between doing it that way and doing it the conventional standard programming language way? All right, so let's get started. We're going to have parameter. We're going to have a parameter n, and let's say it's going to be 100. Just 100 variables. We're going to populate our vectors with 100 variables. We'll have a vector A, and we'll put into it 100 normally distributed numbers. Then we'll have a vector B, and we'll also put 100 normally distributed numbers into that vector, right? So let's run this. There's n, there's A, and there's B. Perfect. Now what we want to do is we want to compare the difference between running a vectorized operation and a devectorized. So let's put a comment in. So this is going to be vectorized approach, and then we'll have a comment as well, devectorized approach. I think I should put a dash in here. All right, so let's do the vectorized approach first, right? We want to create a vector C, and into that vector we want to put We want to multiply A times B. A times B. Done. That's it. That's one line of code. Finished. Now for our devectorized approach, what we're going to do is we're going to go through all of the elements and multiply them one by one. So let's look over here. This is A, this is B. We're going to create a loop, and we'll take the first element, multiply it by the first element, and store it in a separate vector. Then we will multiply this element by this element and put it into that vector as well. Then we'll multiply this element by this element and put into that vector as well. So let's see how we can arrange that. First, we'll create a vector D. And into that vector, what we're going to do is we're going to create an empty vector. So we're going to use the replicate function, and we're going to replicate a simple NA. So NA stands for not applicable or something like no value. It's not existent. So just basically we'll create an empty vector, but what we're doing is we're allocating memory. We want to allocate enough memory for this vector, right? So now we have vector D, which is a logical vector. Well, it doesn't really matter what kind of type it is, and it has 100 elements, all of which are NA. So, but basically what that means is that now we have 100 spaces that we need to fill while we're going to be multiplying the two vectors. And now we're just going to add a simple for loop, as we discussed previously, for I in 1 to n, right? Because we have n elements. We're going to, what we're going to do is we're going to say D with the index I. What we want to put in there is we want to put in there A with the index I multiplied by B with the index I. So very similar to what we're doing here. We're accessing the vectors element by element, we're multiplying them and putting the result into D. So let's go ahead and run these two approaches. So first of all, let's run the approach for vector C. And now let's run this second approach, the devectorized approach, and calculate vector D. Okay, so here we have vector C and vector D. As you can see from these two lines, they are identical. So we've got the same result. Now, what are the differences here? The differences are obvious. First of all, this is way shorter. This is quite cumbersome. It takes some space. It takes actually 4 lines, and you've got a loop. You've got to code more. So it's visually not as aesthetic, and also it takes more time to create this code. But what isn't obvious right away is that this approach is actually faster. Yes, in R, vectorized operations are faster than devectorized operations. And I can actually prove it to you. So let's change n from 100 to 1 million. So there's 3 zeros, there's 6 zeros. So if I change n like that, now I rerun A and B, and I run this, watch how long it'll take to run. Pretty much instant, right? So now if I run this, first I'll create the vector, and let's see how long this loop by itself will take to run. You can see it's taking some time, right? Now let's say I make it 10 million. Run that, watch how long it'll take for this to run. That was like maybe half a second, maybe less. Now let's allocate some space for D, and now let's run this part. As you can see, it's still thinking. And it's still thinking. And again, the computer is still thinking, even though we're achieving the same result, exact same result, but just in a different way, it is taking longer. There we go. So here you can compare that, well, both vectors are here, you can actually see them. But the point is that this one took way longer. So why is that? And in fact, this can come as a surprise for those of you who have experience in other programming languages, because a lot of programming languages, especially low-level programming languages like C, they will work better if you break down operations into small blocks like this. So if you create a loop in C like this, it will work much faster than something that is similar to a vectorized operation. In fact, the programming language Julia, it also has vectorized and devectorized approaches. Well, in Julia, if you create a vectorized approach, it'll be longer than a devectorized approach. So the opposite, the flip happens there. So why is that? Why is that the case? And here we'll get into a bit of like technical details around R, which you might not come across in other tutorials or in other books that you read on R, but I think it's important because it helps you better understand what's going on in the programming language in the background, and also it helps you optimize your code and ultimately produce better scripts. So what's happening is R is a high-level programming language, and things like this, vectorized operations and function calls and so on, even without you realizing it, what it's doing is it's delegating those things, those calculations, to programming languages like C and Fortran in the background. So you can't see this happening, and you think that R is doing this calculation, or R is performing a function that you've called, executing that function. But what is actually happening is R is basically acting as a wrapper for C code, or for Fortran code, or for some other programming language code, and it's basically calling that language to perform its hard labor for R. And what it needs to do is, when it's calling that language, for instance C, it has to tell that language what it's passing, what kind of variables it's passing, and what needs to be done. And for instance here, it has to tell that delegating a programming language, it has to tell it that this is going to be a double variable, and this is a double variable, and this is a double variable, and you need to multiply them and then assign them here. And then it has to do that. What do we have here? It has to do that 10 million times. So 10 million times it has to tell C what kind of variables it's passing on and what needs to be done with them. When you perform this approach, what happens is R relies on that fundamental concept that we talked about earlier, that a vector can only contain elements of the same type. So R will know already that this vector can only contain doubles, right? And this vector can also only contain doubles, because it just has to look at one of them and it will know, because it knows that you cannot mix different elements inside a vector. So it will only have to tell the other programming language one time what kind of variables are being passed, and it will only have to tell that programming language exactly what to do, the multiplication and then the assignment operation, that it will only have to pass that information on one time. And that is where the time is saved, in that delegation of tasks. And then the low-level programming language, which is C or Fortran, it takes this operation and breaks it down, and then the loop happens in there automatically. And so that is the second reason why you should use vectorized operations in R as opposed to devectorized operations. Because even though you might think it's faster to do this, in reality it's not. It's much faster in R to work with vectorized operations. Okay, so I hope I didn't bore you to death with that explanation. I personally believe that knowing the nitty-gritty of the tool that you're working with can be very beneficial for you in the long run. Okay, so that brings us to the end of today's tutorial. Hope you enjoyed it, and I look forward to seeing you in the next one. Until then, happy coding.